Imagine looking up and seeing this luminous cloud, an entire galaxy just hanging there. Well, for people in the southern hemisphere, that's actually real. It's the Large Magellanic Cloud, the LMC. Today, we're doing a deep dive looking at the sources you provided to really unpack this cosmic neighbor. We'll cover its sheer scale, its structure, some really recent kind of bombshell findings about its black hole and, well, its future. A pretty dramatic collision with us, the Milky Way. It's basically a story of gravitational chaos unfolding right next door.
It really is a remarkable object, and mostly because it's so close. The LMC, well, it's a dwarf galaxy, technically a satellite of our own Milky Way.
Wow.
And it's only about 163,000 light years away, give or take. That puts it as, the second or third closest galaxy to us?
Yeah.
Its condition right now gives us this direct look into a messy, active galactic tug of war.
Okay, let's talk about that scale for a second, because it's pretty massive for a dwarf galaxy, isn't it? We're looking at something like 32,200 light years across, and containing, estimates say, maybe 20 billion stars. That's quite a lot. And for visibility down south, it's like a faint smudge, but huge. Covering an area maybe 20 times the diameter of the moon, you can find it sort of straddling the constellations Dorado and Mensa. Now, before we dig deeper into its, let's say, turbulent history, a quick word about our sponsor, embersilk.com. Embersilk is the answer for all your AI education and integration needs. Find them at embersilk.com.
So structurally, the LMC's class is a Magellanic Barred Spiral. SPSM is the technical term. And while everyone knows the name from Ferdinand Magellan's voyage in 1519, the sources actually point out that the first recorded sighting was a bit earlier. Amerigo Vespucci, it seems, noted it down in 1503 or 1504.
Interesting. So Vespucci saw it first officially.
It seems that way. But what's really key about its structure today is its shape. It's not simple. For decades, the thinking was, it was basically a flat disk.
Right.
Relatively straightforward. But more detailed measurements show it's complex. It's got this inclined geometry, maybe tilted about 35 degrees relative to our viewpoint.
Mm-hmm.
And crucially, that central bar, it appears noticeably warped.
Warped. So physically bent out of shape.
Exactly. And that warping is, it's basically physical proof of the intense tidal forces acting on it.
So it's being stretched and pulled by the Milky Way on one side and its smaller companion, the Small Magellanic Cloud, the SMC, on the other.
Precisely. It's caught in this gravitational tussle.
Right. And when you connect that kind of stretching to what's happening inside the LMC, it really earns that name astronomer Robert Burnham Jr. gave it. He called it an astronomical treasure house.
So what are the highlights in all that chaos?
Well, the LMC is incredibly dynamic, a real powerhouse. It hosts the Tarantula Nebula, and that isn't just any nebula. It's the most active star-forming region in our entire local group of galaxies. The most active. Wow.
Yeah, stars are being born there at incredible rates. And then there's history, like supernova 1987A. That was the nearest supernova we've observed in, modern times. It gave us unprecedented data on how massive stars die.
And you can actually see the connection to the SMC, right? This bridge of gas.
You can. It's literal evidence of the gravitational interaction, this stream of hydrogen gas linking the two galaxies.
The dynamics just keep coming. There was a finding announced not too long ago, March 2025, something pretty unexpected at its core. They found strong evidence for a supermassive black hole, estimated at, 600,000 times the mass of our sun. Now, is that considered big for a dwarf galaxy?
It's definitely significant. And it really changes the story about how these smaller galaxies might evolve or influence bigger ones. The main implication, according to the research, is that this black hole could be acting like a kind of gravitational slingshot.
A slingshot? How so?
It's thought to be responsible for kicking out extremely fast stars, we call them hypervelocity stars, out of the LMC and into the Milky Way's halo. There's a process called the Hills mechanism that could explain it. So even as our neighbor, it's kind of bombarding our galaxy with these stellar projectiles.
And it's actively messing with our galactic environment even now. And the biggest disruption is still on the way, isn't it? The prediction is that this whole galaxy, the LMC, is going to merge with the Milky Way.
That's the current thinking, yes.
Yeah.
In about 2.4 billion years.
Wow.
And if you connect this to the bigger picture, the LMC really forces us to reconsider galactic evolution. Our sources suggest that even a quote-unquote small satellite galaxy, especially one with a fairly hefty central black hole like this one, it can be a major catalyst. It can drive significant changes like triggering star formation or these star ejections, or even ultimately merging in massive galaxies like our own Milky Way.
This spectacular and, chaotic cosmic fate indeed. It's quite a neighbor to have. Well, if you found this deep dive valuable, please do subscribe and maybe give us a 5-star review. It genuinely helps us out a lot. And for anyone wanting to dig into the sources themselves, the links are right there in the description. And one last time, a thank you to our sponsor, embersilk.com.